Hello everyone, welcome back to another video. So this video will be the presentation of my digital assignment 2 of the course Computer Organization and Architecture. My name is Yash Maheshwari. My registration number is 18BEC0205. I am from slot A2 and my serial number in the slot is 23. This project was done under Professor Dhanawal R, and I would like to proceed with the presentation. So this project was based on a general paper which had to be selected by us, which was related to our curriculum in computer organization and architecture. So the research paper selected by me had the title Design of Low Area and High Speed Pipeline Single Precision Floating Point Multiplier. Okay, again some general details about myself. Proceed. So, the question one was how the selected paper is related to COA syllabus and curriculum. So, this is the relation between the project and the assignment and the syllabus. So, the floating point unit is a part of computer systems specially designed to carry out operations on floating point numbers. Floating point numbers are generally basically come numbers which has decimal in them. So typical operations are addition, subtraction, multiplication, division, and square root. Some F, some floating point unit, which are FPUs, can also perform various transcendental functions such as exponential or trigonometric calculations, but the accuracy can be very low. So that some of the system prefer computing these functions in software. Floating point multiplication is a common operation in computer organization and architecture. So this is one of the reasons the paper selected by me is related to our course, computer organization and architecture. So the paper selected explains the 32-bit binary floating point multiplier (FPM) architecture using an area-efficient array multiplier. The proposed multiplier generates only the need of MSB bits, which is the most significant bits of the product Mantissa by making the use of divide and conquer algorithm with a modified full adder to increase the speed of multiplication. The first section of rounding error discusses that the implication of using different rounding strategies for basic operations of addition, subtraction, multiplication, and division. It also contains background information on the two methods of measuring rounding error, ULPS, and relative error. The second part of the paper discusses about floating point standard, which has become rapidly accepted by commercial hardware manufacturers. So this is the basic gist of how the selected paper is related to our curriculum of computer organization and architecture. If we read the whole paper, we come up with the following answers. So the question 2 is draw the existing architecture discussed in paper using appropriate raster graphics editor software. Okay, so I have used apps.diagram.hand, which is draw.io, as a tool to draw the required diagrams. Also, I have pasted the screenshot of it below, and I have attached the EPS file on Google Drive link, and the Google Drive link has been shared in the Google group itself. So this was the diagram given in the research paper, and this here is the work which was done by me on an online platform using an online tool. It was basically to get the full information in the diagram itself. Okay, so the question 3 was draw the tabulated results and graph using offsuit and we have to post them in EPS format. So the paper represents a floating point multiplier FPM architecture using an area efficient multiplier with a modified full adder. The proposed multiplier was designed to generate only most of the significant 25 bits from the Mantissa application of the two single precision input numbers, as the only bits are required to obtain the final result. So these are some data which was provided to me in the research paper itself. It has following graphs which explain methods with pipelining and method results with pipelining and results without pipelining. So there is some delay, total power consumption, leakage power, cells, area, and this is just the simulation. Okay, moving on. Draw the proposed architecture discussed in the paper using diagramming and vector graphics application software and EPS file format. So some basic theory background. about the research paper. The paper proposes a single precision floating low power multiplier that conforms to IEEE 754 standard. This is the standard provided. This is one of the standard provided by IEEE organization for low power multiplier. The 24 cross 24 significant multiplication is achieved by the using of four parallel 12-bit multipliers. Each of these are implementing using radix 4 modified Booth algorithm using. So I have posted the screenshot of the diagrams below. So this is the basic diagram of the proposed architecture. I have shared the diagram drawn by me using online tools in the Google Drive itself, as it was not uh, as it was mentioned during to us in the class. Okay, question 5 is draw the transistor level internal diagrams using electronic schematic capture and using and post them in EPL. So as discussed earlier, it has 24 cross 24 multiplier and it consists of several gates which are XOR gate, and there is some 8-bit adders, 9-bit subtractors, normalizer and multiplier final cell. So this will be giving us the final answer of the operations we have performed. So this diagram is also drawn by me and the same is attached in the Google Drive link in my folder under the registration number 18BEC0205. Okay, so now we have to compare the proposed architecture with existing architecture in your reference book. So in the proposed architecture, the simulation results in FPGA are given to verify the correctness of the design. So this is to basically make the results accurate enough. The design saves the resources by comparing the floating point operation with common algorithm 32-bit floating point of IEEE standard. So everything, the paper I choose was published under IEEE organization. So it follows all the standard requirements which have been allotted and published by IEEE, which is a very esteemed organization. The Booth algorithm, which is in the reference of books module 2, has module 2 of our curriculum of computer organization architecture, has a history of inaccuracy because of use time consumption. Question 7 is list the advantage of proposed design over existing design. So this is just a theory answer, and this was this I got the all this information provided in this answer from the research paper, and I had to frame this in all my words. So I have done that. For example, the proposed architecture requires lesser power, that is 19.2% less than FPM, which is floating point multiplier using Booth multiplier. It also uses a delay of 0.53 considering compared to existing Booth multiplier. So this means the method chosen by me is fast as well as efficient. All the functions are built with feasible efficient algorithms with several changes incorporated that can improve overall latency and a pipeline then higher output throughput. Question 8, moving on. List the merits and demerits of the proposed system. So merits are the design saves the resources by comparing the floating point operation with common algorithm of 32-bit floating point data of the IEEE standards as discussed earlier. By changing the number of digit control port signals to realize the adjustment of the whole data, the number of multipliers in the multiplication part of the multiplicator is reduced. By controlling the change of data format, the selectable architecture of high computing precision and low computing resource consumption is realized in the operation, and at the same time, the working frequency is greatly raised in the case of using custom data structure. Although some demerits are, although requires less time, it requires more internal storage. Old ways of hardware implementation need to change for betterment. There is need for more attention due to complexity of. So this all merits and demerits were calculated and given by me using using in-depth comparison between the styles which are present now and styles which have been used by us from the some past times. Okay, so question 9 is list the application of proposed design. So application of neural networks. Neural networks is one of the most esteemed fields today in the field of science, and the discussion below is just a expression of how the research paper has its application on neural networks. Okay, so question 10 was to draw the flowchart or algorithm transistor level circuit proposed in the and propose it in EPS format. So this is the diagram which was given to me in the research paper, and I have attached this diagram in the Google Drive itself. I have drawn it on draw.io platform, and I have used normal tools which helped me in uh, making things easy for me as well as learning new concepts. So I like learning using new tools. So yeah, these all diagrams which are presented to me in this video have been attached by me in the Google Drive in DA2 folder under 18BEC0205. So this is the link of I3 to triple E paper. This and I have also uploaded the IEEE format IEEE paper, which is the paper chosen by me for this assignment, and I have uploaded the PDF file of that in the Google Drive. So thank you. This was it for me. Thank you, sir, for giving me an opportunity to learn these subjects, these course, and these vast range of questions, which helped me increase my knowledge and helped me. Uh, it helped me to keep myself updated in the modern technologies. So I am Yash Maheshwari. 18B is I'm Yash Maheshwari, 18, registration number 18BEC0205 of slot A2. My teacher is Professor Dhanabal R. I am from Vellore Institute of Technology, and this was my presentation for my assignment 2 of computer organization and architecture. Thank you very much.